Hi folks, and welcome to video number 99. This video is on perpendicular lines. Now the keywords here are perpendicular and negative reciprocal. Perpendicular means at right angles to, so if two lines are perpendicular they are at right angles to one another. And the negative reciprocal is if you've got a gradient of a line, well, if you've got any number, in fact, if you've got a number, let's say 2/7, if we flip it upside down and make it negative, we've found the negative reciprocal of that particular number. And this does relate to the gradients, all right, because the lines that are perpendicular to one another have negative reciprocal gradients. Okay, our method states that we need to find the gradient of the line segment that you're given and then work out the gradient of the line that is perpendicular to it using the fact that I just mentioned. Sub the x and the y coordinates and the m value into y equals mx plus c, solve to find the value of c, and then sub the m and c values into the equation for the equation of our perpendicular line. So we get given an original equation. We have to work out the gradient of that original equation, and if we are doing that, we can call it m1. All right, now I'll put a little formula up the top there, and that's m1 multiplied by m2. So original line's gradient multiplied by perpendicular line's gradient will always equal -1. All right, that's something that we can know and is useful for us. It's not entirely necessary. But in this particular first question, we've got a number that's in front of x. That is our gradient. All right. Now, if I pop that number over 1, it hasn't changed the number. 3/1 is still the same as number 3. So m2 is going to be 1/3, but made negative. Okay. We have the negative reciprocal to the original line. So that is the gradient of our perpendicular line to this one. The second question there. All right. B, you got 12 in front of the x. So m1 is equal to 12 over 1, so m2 is equal to -1/12. Kind of get the idea. Relatively simple. Make it negative, flip the numbers in the fraction around. And the last one, we've got the -5 there. Okay, so m1 is equal to -5 over 1. So if it's already negative, m2 is going to be negative, right? So flipping those numbers round, we're actually just going to have a positive gradient of 1/5, right? Because the gradient of the initial line was already negative, so our perpendicular line is going to have a positive gradient. Right, so that's just finding the gradients. That was nothing too tricky at this stage. But then we're going to use our method for question number 2, I think. So find the equation of the line that is perpendicular to y equals 2x plus 5 and passes through 0, 3. So basically we need to kind of find m1 first of all. So m1 is 2, therefore m2, we could put therefore with the 3 little triangle dots. Therefore m2 is equal to the negative reciprocal of this, which is -1/2, -1/2. Okay, now we've got the x and the y values here. All right, this is not too tricky. So y equals -1/2 of x plus c. We could substitute into this, right? But if we've got 0, 3, we know that's going to be the y-intercept anyway. I'll just show you through example. But 3 is the y value. It's equal to -1/2 multiplied by 0 plus c. And if you multiply anything by 0, it's just 0. So we end up with 3 is what c is. C is equal to 3. So we can write our equation in the form of y equals mx plus c for our perpendicular line because we've got the gradient of it and we've got the c value. Okay, so we've got y equals -1/2 of x plus 3. All right, I hope that makes sense. And if you're not sure what's really going on, go back and watch some of the other videos that I've done on y equals mx plus c. All right, that would be really useful because I've gone through it a little bit slower in that example, I think. So move myself over to the third and final question. Most complicated one. So find the equation of a line that's perpendicular to, then we've got this equation here, passes through this particular point, give your answer in this particular format, where a, b and c are integers. So that is slightly more complicated because there's more stuff going on, but it starts off the same way. So we can still get m1 quite easily. We can look at the number that's in front of the x, stuck next to the x, is a -5. So m2, the gradient of the perpendicular, is going to be positive, and it's going to be 1/5. All right, so we've got 1/5 to substitute into y equals mx plus c. So y equals 1/5 x plus c. Got the coordinate value which we can chuck in, so that's 5 is equal to 1/5 multiplied by 20. And I'm going to put that over 1, as I've mentioned before. I like to do if I've got fractions to multiply. 20 divided by 5, effectively, that's going to turn into. So that's I'll just write it out like that: 20 over 5 plus c, because 1 times 20 is 20, 5 times 1 is 5, and then we know that 20 divided by 5 is actually 4. So 4 plus c, and then we take away the 4, so c is actually equal to 1, right? So take away 4 from both sides, that's what we got. And that's pretty tricky, I guess, to that point, but you know, it's y equals mx plus c substitution, isn't it? Right? All we did was have to find that value and chucked it in, and then all we've got to do is write our equation out in the format that we want it in. So we've got our gradient and we've got our y-intercept, so y equals 1/5 of x plus 1. I'm going to multiply each of the terms through by 5, so 5y equals x plus 5, and then I'm going to rearrange to the format that we want it in. So that's going to be something x, it's going to be minus x plus 5y is equal to 5, but we don't want that 5 on that side, so minus 5 is equal to 0. There's our final answer, just rearranging this into this format. So minus x plus 5y minus 5 equals nothing. All right, and that's that. That is one of the most complicated examples I guess you'd get. We're going to use this skill later on down the line when we're finding the equation of a tangent to a circle, which is quite interesting, but that's about as difficult as it might get for you on just this particular skill. So I hope you enjoyed watching that one. Please do watch another one. The next one will be the 100th video. Do something in that video for you, make it slightly more interesting, if there is a way of doing that. So yeah, thanks very much. Click the link in the description. Watch another one. See you next time.